All right, here's your review for Chapter 8 on sequences and series, arithmetic and geometric sequences and series. All right, so on the SOL or on your test next Thursday or Friday, you will have these formulas given to you. We really only discussed a few of these, or there's some of them that we haven't discussed because you don't really need them all the time. So basically, here's what you need for arithmetic. There's your nth term, or if you were looking for a formula for what's going on, and here's the sum. The other two are useful, but you can get by with just knowing these two and knowing how to use them, which we've done in class. All right, for geometric, you need 3 of them. You need the formula for the nth term, you need the sum of a certain number of terms, and the last one, you need a sum to infinity. You can only do a sum to infinity with geometric, so that should be a good clue right there. So basically, these other ones right here, we do not necessarily need all the time, and you're good to go without them. All right, so here we go. So number 1 says, what's the 12th term of the arithmetic sequence with the first term of 8 and a common difference of 5? So arithmetic, it's adding and subtracting. So if you're desperate, you could sit here and be like, 8 plus 5 is 13, 13 plus 5 is 18, 18 plus 5 is 23, and you could go on and find the 12th term. Well, we're going to use it, do it using the formula. I need my nth term. I don't need a formula, so I don't really need to get the whole formula. I have a1 plus n minus 1 times d. So if I want the 12th term, a1 is 8 plus, I'm doing the 12th term, so this n minus 1 becomes 12 minus 1. Well, 12 minus 1 is 11, and my common difference is 5. So 11 times 5 is 55. 55 plus 8 is 63. So there we go. All right, number 2, find the formula for the nth term of this arithmetic sequence. Okay, so you can see it's going down by 10 each time. So there's my common difference is 10, and my first term is 32. So we're just going to use this formula right here and fill it in. I got an, a1 is 32, plus I got n minus 1 times d. Whoops, d is 10. Oh, d is negative 10. Sorry about that. So there's a negative 10 right here. So we got to clean that up. All right, so realize what's happening here. Negative 10 is multiplying by both of those pieces. So negative 10 times your n will be negative 10n. And then negative 10 times a negative 1 is a positive 10. Well, I have a positive 10 and a positive 32, so I got plus 42 coming at me. All right, so if somebody asks you to find the sum here, and you can use your calculator. So of course on number 3, if you need to use your calculator, you press the math button. Oops, I need a pen in there. You press the math button and scroll around to part 0 there and get it that way. Or if you don't remember that, you can do alpha window, and there it is, number 2. All right, so either way you got there. Don't use n, use x. Jumps over to 1. And let's see, up to 15. And of course, just put 4 minus 3x in there. All right, so you can very easily do that on the calculator, but so you can see that there. But if you have to do it by hand, it's very simple also. This is a summation, so I want the sum of 15 things. Well, my formula says to do n over 2, so 15 over 2. And then it says a1 plus an on the last page. So a1, well, a1 is the first term. The first term is when I plug in the first number you're telling me to plug in. So I plug a 1 right there. So put a 1 in there. 4 minus 3 times 1 would be 1. Plus the last term. Well, the last term is when I plug the last number into my formula. So 4 minus 3 times 15. So it'd be 4 minus 45. Right? 4 minus 45. Yep, negative 41. So there we go, and that would eventually, put that in your calculator, you get the same thing, negative 300. All right, number 4. Number 4 says find the sum of the first 10 terms of this sequence right here. First of all, I need you to do this. Made a little mistake here. Cross off these last 2. They do not follow the correct pattern. All right, so we want the sum of the first 10 terms. It did say arithmetic, so I'm using that same formula that I did right there. So I will putting 10 over 2. First term I can easily see is 3/4 plus, the problem is I need the last term. I need to find the 10th term right here. So I'm going to go over to the side and use my formula from up here this one up here to go ahead and find the 10th term. So the 10th term is the first term, which is 3/4, plus n minus 1. Well, 10 minus 1 is 9, times a common difference. Well, the common difference I see is adding 1/4. 3/4 plus 1/4 is 4/4, which is 1, and 4/4 plus 1/4 is 5/4, so that's how it's getting the next thing. If you don't know that, you could just take and subtract, do like 1 minus 3/4, or you could do 5/4 minus 1. Both of those would get you 1/4. That would be your common difference. So that goes right here. All right, so put that in your calculator or do it in your head. You get 9/4 plus 3/4, that would be 12/4. 12/4 is 3. So that number goes on the tail end right here. Excuse me. All right, so I can see that the beginning part is 10 over 2, so I'm just going to put 5. And then inside here I have 3/4, so you can make a fraction if you want to, or put 0.75. And then I have plus 3. All right, so here we go, 75 over 4. Or the decimal that represents that. All right, number 5. Given the first term of a geometric sequence is 5, so it's a multiplying pattern, and the common ratio is -2. Find the 7th term. So you do have this option. You start with 5, you multiply by -2, that's -10. Multiply by -2 again, I get 20. Multiply by -2 again, I get -40. So you could keep that going and pretty easily find the 7th term. Well, but geometric is pretty easy to write. The nth term is the first term. In parentheses, you put the common difference, or common ratio, and then you put n minus 1 up here. So you could also easily just plug in 7 into this formula. So a7 would be 5, -2. If I put a 7 right here, 7 minus 1 is 6. So if I do that, let's see. 5 parentheses -2 to the power 6, and we get 320. Alrighty, so last little bit here. All right, find the sum of the infinite geometric series. So infinite geometric, that's where we use our one formula, only one we had for infinity. That's a good clue for that one, over 1 minus r. So in this case, I would be saying 18 is my first term, my common ratio. So oftentimes it's the common ratio that's hard to find here. Well, to find the common ratio in any pattern, you take any two numbers and divide them. So I'm going to use some of the easier numbers. So I'm going to take like these two numbers. You always take the last one divided by the one before it. So I'm going to take 2 and divide it by -6. Well, that's -1/3. Now, nobody says you have to reduce it. I'm going to put -1/3 in my problem, but you could use -2/6 if you want. So I do 1 minus -1/3. All right, so literally just type that in your calculator. You know that it's 1 plus 1/3. You could clean it up to that, but make yourself a fraction. Put your 18 on top. Go down. I got 1 minus a negative, and then make another fraction. Oops. And put a 1/3 in there. All right, there we go. So 27 over 2. All right, and the last one here, let's see, says find the sum of the first 8 terms of this geometric sequence here. So you can see if you divide or if you look at it, you're like, oh, they're just multiplying by -3. So there's my pattern. If you do -12 divided by 4, that also gets you -3. That's your R value. So if I want the sum of the first 8 terms, I have to use that big fraction. The fraction says A1, so I put 4, the formula. And here I put 1 minus r to the n. Well, r is -3, so you got to hold it together with parentheses, and then put an 8 up here for your n. The bottom, you do 1 minus r, so 1 minus -3. So clearly you can see that that's plus if you want to put that. All right, so it's all about just typing that in your calculator. I don't know why this thing got so small. There we go. All right, so make yourself a big fraction. Oh, this calculator is bothering me. I got 4 parentheses, 1 minus. Now you cannot cancel out these two negatives right here. All right, one of the negatives is in the parentheses and the other one is not. So the 8 has to go with the negative in the parentheses. So you had to put the parentheses put the -3 inside, close your parentheses, then put power 8. And then go and close the other parentheses that you started. So type it exactly like you see it. And then 1 plus 3 on the bottom, we just put 4. There we go. -6,560. All right, over here. Let's see. So what is the sum of the infinite series? So you have the option here. You can put this in the calculator if you want. Go ahead and find your sigma notation, however you like to find it. Put x equals 1. And there's no infinity symbol on here, so I'm just going to pick a big number, like 100. Don't pick too big, because in the calculator it takes too long to think of the answer. So make sure you type in what you see, the 200 part, inside here. So 200, put your own parentheses, put your fraction of 1/2. Now it's very important also that after the 1/2, don't use the parentheses that's already there. Close your parentheses and then put your power of x minus 1. Everything in your problem has to be inside the parentheses that the calculator puts, because the calculator puts its own parentheses. You're not allowed to use those. All right, so press enter. I'll be thinking about it for a minute. And it'll give you the answer of 400. All right, but it's also easy to use your formula. Sum to infinity, I need first term. Well, there's the first term sitting right there. And the bottom, I do 1 minus r. Well, here's r sitting right here. So that will also give you 400. All right, number 9. Number 9 is a recursive sequence. So recursive means, remember, that means that the answers recur in the problem. So every time you see this little thing right here, that means you're calling back into action the last answer. So when somebody says start with 3, then this right here is the formula for the next term. I need to do 8 plus 2, and this little piece right here is calling back the last answer. So 2 times 3. So let's see, 8 plus 6 is 14. Well, when I want to get the next answer, well, that's going to call back the last answer. So I still do 8 plus 2 times, well, this calls back the last answer. The last answer was 14. So that's 28 plus 8, that's 36. Oops. All right, so notice it's every answer is recurring and being used again. Oh, yeah, the 7th term, let's see. So I want 8 plus 2 times 36. So let me see, that's 72 plus 8, that's 80. All right, and then the next one, 8 plus 2 times 80. All right, so that's 160 plus 8, that's 168. All right, now I need my calculator, I think. That's 3, 4, 5. Let's see. I need 7 terms. So now I got to do 8 plus 2 times 168. Then I have to do 8 plus 2 times 344. So you're always using the last answer in your new answer. So 696. So 696. All right, and we got the there on the board. You can write it down on your paper. All right, so sum of infinite geometric series. So there are those words again. Infinite, geometric, so you got your sum to infinity. I need first term, so that's 9 over 1 minus, well, I need my r value. So my r value, take any two numbers and divide them, but take 1, divide it by the one before it. So I'm going to take the -6 and divide it by the number before it, 9. So that's -2/3. The calculator doesn't care if you reduce it or not, but I did, so I'm going to put it right there, -2/3. All right, so then it's just a matter of typing it. All right, so I need a fraction. I got 9 on top. I got 1. You can put minus and minus, so I'm just going to go ahead and put plus to save time, and then make another fraction and put in 2/3. There we go. 27 over 5. I feel like we did this before. Maybe that was a repeat, sorry. All right, next one, I guess number 11. All right, so here, what's the sum of the first 20 terms of the arithmetic? So there was a clue, arithmetic, so there's an adding pattern, and notice, I'm just adding 1/3, adding 1/3, adding 1/3. So my common difference is 1/3. All right, sum of the first 20 terms, so I want S20. So I take 20 over 2 for my formula. A1 is easy, that's 1/3, plus this is the bad part. All right, I don't know the 20th term, but I can easily find it. So 20th term will be the first term plus n minus 1, so 20 minus 1, which is 19, times a common difference of 1/3. Well, that's easy enough. I mean, it's just 1/3 plus 19 thirds, so that's 20 thirds. All right, so I got 20 thirds right here. And also that's pretty easy because in the front here, this is 10. 1/3 plus 20 thirds is 21 thirds. And that's 10 times 7 then, so 70. So see, it's not that bad to do without your calculator. All right, last one here, right? Oh, 2 more. All right. Infinite. So sum to infinity, first term's 100, divided by 1 minus, I need my common ratio. Any two numbers gives you your common ratio. So my common ratio, 60 divided by 100. So you can just put that 60 over 100 right here. Or we could reduce it. I could cancel out the zeros, so now I got 6/10. And reduce that more, I get 3/5. Okay, so I'm going to put 3/5 right there, but you could just as well have put 60 over 100. The calculator's not going to care. Let's see, make a fraction. Make another fraction. All right, 250. All right, last one. Now, I do notice on here that on this review sheet, there's no arithmetic means and geometric means, but we did practice those in class in your packet. So make sure you go back and look at those either on your homework or on your packet. You know, they're not on here, and they will be on your test. So let's see, 14th term, arithmetic sequence. First term is 7, common difference is 10. All right, so I'm looking for a term, so I'm using this formula. All right, first term 7, and minus 1. Since I'm doing the 14th term, I will put a 13 here because 14 minus 1 is 13, and 10 goes out there. So quite easy, I get 7 plus 130, so 137. There it is. And you do have the option, you know, if you really want to, you could start with 7 and start adding 10. 17, 27, 37, 47, until you get to this 14th term, right? So you could do that too. Since it's multiple choice and nobody needs to see your work. All right, I'll see you in class. Bye-bye.